We're going to answer 3 questions. First of all is, why is it relevant to talk about ZOS Connect EE in the same breath with HostBridge? Secondly, how should we use, or how do you use ZCEE with HostBridge? And by the way, we use ZCEE as the common acronym to describe ZOS Connect EE. And that is very simply because I get really tired of saying ZOS Connect EE so many times during a presentation. So ZCEE is my shorthand way of saying that. And then we're going to talk about some resources that we've actually specifically developed to help you, if you're interested in playing around, to kind of get a head start in doing that. Let me just start with some background information and particularly focus on kind of some of the things that are going on. BMC periodically does a really nice mainframe survey of the market, and they did one in September. And there were a couple of questions about modernization and transformation. I wish I could have contributed a few questions, but nonetheless, you know, we at least could see some trend lines there. Many of them, a majority now, have some increased use of Java on the platform. So in other words, we're seeing signs of new design patterns, new languages, new life on the platform. And almost half have adopted ZOS Connect in some way to do certain things. These 2 integration solutions enjoy very robust adoption. So particularly, we think ZOS Connect is very relevant or we know it's relevant in our customer base and in future customers as well. So let me, first of all, just issue a disclaimer about ZCEE, and I do this in much deference to my IBM friends who have designed and built this product. ZCEE supports a broad range of IBM subsystems, CICS, IMS, DB2, MQ. It can do a lot of things. It has been designed to very well, and we'll see that in some diagrams, to be kind of create a design pattern that is agnostic to a particular subsystem like CICS, but implement a design pattern that can be used as a building block or foundation for building blocks to build this sort of ZOS connectivity. So ZCEE is big and can do many things. Our discussion, however, we are only going to focus on CICS. So if I say that, from this point forward, if I say ZCEE does this, I'm only referring to that in the context of CICS because it may in fact do something different or work in an opposite way in a different environment. So our focus is CICS. And we developed all this presentation material and a white paper and a lot of sample code based upon the version of ZCEE that was available kind of mid to late 2019. And as with all things, they change. But at that time, the open beta in or around the spring to summer of 2019 was kind of the state of the art. So we are using essentially the most current release that many organizations are using in production. Let me talk about just how we approach integration before we start zooming down into diagrams and details. We think a real problem when it comes to application integration is assuming that all CICS applications are alike for the purposes of integration. And we think making these sorts of rather blind assumptions is the root of many failed projects. We think it's terribly important to understand, okay, what type of CICS applications do you need to integrate with or to? And then to pose the question, what type of integration will do the best job? We can all easily see that if what you have to exploit running under the covers of CICS is a BMS application, that's an entirely different integration scenario than if what you have is a well-behaved COM area program. And so making broad assumptions is dangerous, and we think it's really important to focus on the application characteristics. And that's why we develop a bit of a way to organize these applications for the purposes of understanding how to integrate with them. So For example, this diagram, you'll see arrows here. We're not trying to connect things like clients and servers or anything like that. We're just trying to say that if you take the global set of all applications running on an IBM mainframe under the covers of CICS, there are certain types. They can be broken down into kind of definable puddles. One that's very common, of course, are those applications that have been written as standalone business processes. You invoke them, you give them a set of inputs, they do something, they then return a set of outputs. The classic example would be a CICS business logic program styled as to use a COM area, a communications area, that just simply takes and organizes a set of variables as input and then as output. Now, under type of integration, what we're really asking there is, really it's a style issue. Do we want the API to be formed by one program or multiple programs? And so when we say type of integration, we're going to say, in this example, each API call invokes one program. In other words, we would call this a one-to-one design pattern. Now, this, it turns out, is a common design pattern, less common than everyone wishes, but it is a common design pattern, and it's really easy. So on difficulty, we say, no, this is pretty easy stuff. And in fact, we want everyone to know that ZCEE does this really, really well right out of the box. If what you have are an inventory of business programs organized as COM area or channel and container programs, and there is always a one-to-one relationship between the API you want to expose and the program that is implementing the API request, then you're done. Use ZCEE and you've got exactly what you need. There are other design patterns that also exist and, in fact, in our experience, are far more typical. And so let's look at a design case where the business process, we have a collection of COM area programs, but in order to offer the API that we want to, in order to offer the desirable API, we really need to execute more than one program. We would call that the one-to-many scenario. So we want one API request to come in, and we want a series of programmatic activities to occur. We need a bit of orchestration or organization to be able to say, okay, run program A, take the output of program A, shove it into program B, run B, give it to C, take the output of C, and now that's actually what we're going to send back to the API requester as maybe a JSON document. So one-to-many. Now we're into the world where this is not so easy. This stuff doesn't just fall out of the box. So we would say that this is moderate. Now, the more challenging case, it never fails, turns out to be terminal-oriented applications, or let's say BMS applications, where each API call to the mainframe invokes one or more CICS transactions. This turns out to be the hardest scenario for a number of reasons. One, we have all the vagaries of terminal-oriented transactions. We have all the issues associated with how we're going to orchestrate that, how we're going to extract data from those applications, how we're going to feed, get inputs and feed outputs and all this sort of stuff. We break down the types of apps and integration requirements into three categories, and this is a key part of the message for today. In those second two categories, in the one-to-many case or invoking terminal-oriented transactions, that is not something that ZCEE does. But this is the strength of HostBridge, and this is what has formed the value proposition of within our customer base of our customers using ZCEE as an API transformation layer and then using HostBridge as the API implementation layer. Recently, we've done our own polls, and we were really curious the commonality or the presence of terminal-oriented transactions, applications inside the customers on this webcast. And it was really kind of interesting. 21% said that the primary way in which their application logic was fashioned was 21% COM area or pure business process orientation. 12% said primarily terminal-oriented applications, but the vast majority said a mix, and we think that that represents reality, and that's what kind of it feels like to us, that there is still this 80-20 rule floating around, so that when we initially talk to a customer and we ask them these questions, we're not surprised at all to find somewhere around 80% of the application inventory still having some, tie, whether in large parts or in small parts, to important applications that are still styled as terminal-oriented processes. And of course, this is important to us and to ZCEE customers because supporting these terminal-oriented applications is simply not something ZCEE does. If we begin to kind of lay this into diagrams, we see something like this. And we see ZCEE, of course, running on platform. We have IBM CICS running on the platform. And if, in fact, you have that scenario where it's a one-to-one scenario where you have a business logic program, let's say it's a COM area program or a channels and container program, and it is 100% of the functionality that you want to expose via the API, then raise your hands and be happy because you have the simplest of all cases and you can easily configure ZCEE to do the necessary transformation work and then invoke that business logic program and return a response. Now, if you are like the vast majority of organizations we deal with, you may have a little bit of that, but you probably also have the more complicated cases as well. You want to build APIs based upon multiple artifacts, maybe multiple COM area programs, or based on terminal-oriented transactions. Or maybe you even want to build an API that requires you to run both a business logic program, a few COM area or a few terminal-oriented transactions, and then maybe go directly access some DB2 data. And then you can return the response to the API request. That sort of a design pattern requires something running on platform to be able to do that bit of orchestration, do that bit of automation on your behalf. You might even call it a bit of an RPA, a bit of robotic processing automation activity on the mainframe under the covers of CICS. And we're going to talk about each of these design scenarios a little bit more when we talk about ZCEE architecture. But something is needed on the mainframe. I have to be open-minded about this. I mean, obviously, we wrote HostBridge to fit this exact need, but that's not to say you couldn't go out and write a new COBOL program that would then orchestrate calling various programs and then maybe working to chatter with terminal-oriented transactions or whatever. But HostBridge exists and our JavaScript engine exists so that you don't have to do that and you have a more cost-effective and a more results-oriented platform that can solve a broad category of problems. I want to use this chart to drive home, again, two phrases that I have used before and that IBM and HostBridge believe capture in large part what we do. ZCEE focuses on API transformation. We, HostBridge, focus on API implementation. Now, that's not to say that HostBridge couldn't do a little API transformation and ZCEE can't do a little API implementation. But by and large, that's the division of labor between ZCEE and something on the interior side of CICS. I don't want to belabor the point of the JavaScript engine, but I do just need to say a few things just to clarify. Usually in this part of the presentation, someone might ask a question, now where does it run? So I want to be painfully clear that our automation engine, which we call HB.js, it runs natively under CICS. It's on your mainframe. It exploits CICS and Z, and it's zip enable. And it lets you author any sort of an integration or orchestration script or in the modern language, we might call it a bot. Anything that ZCEE can invoke, we can essentially be that API implementation. And we'll see that in a couple other diagrams. So everything we're describing on all of these slides is occurring on platform. Now, if you've dug into ZCEE, you know that everything in ZCEE is organized around one particular paradigm, and that is that of service providers. So if you look at the documentation, you'll see lots of different service provider types. When you're going to CICS, there are 3 service providers that are most relevant, and these are their names. It's the CICS COM Area Service Provider, the CICS Channel Service Provider, or the REST Client Service Provider. We are going to focus on the last 2, which is why they're in bold, because we think that not only are they more applicable to driving an automation engine like HostBridge, but they're just so much more flexible. Now, in the one-to-one case that I showed you earlier, where you're using ZCEE to do API transformation and then calling a single COM area program, you would most likely use that first option as your service provider pattern. But we're going to focus on the other 2 because we're focused on these more complicated cases where we want to run multiple programs, multiple transactions, and maybe even go after a little data at the same time. Diagrammatically, if you look at various IBM docs or presentations, you'll see kind of a left to right flow that looks like this, and this is very generic. So we have an end user or something acting as the API requester on the left, and we ultimately have some sort of a ZOS asset on the right, acting as the implementation of an API. In the middle, we have ZOS Connect EE with 3 very clear building blocks, something that is managing and expressing the actual API boundary. The blue box in the middle being a so-called service. And that service is really where the API transformation would occur if it's required. Not all the time do you have to do transformation, but it's nice to have there. And then that edge connector there where it says service provider, that is that edge connector to that other ZOS to the asset of whatever kind. So this is a very generic diagram, but now we're going to start laying in some details on it. So we still have the transformation and the implementation, but now let's look at this as the CICS channel service provider. Okay, in this case, the service provider box will be the channel service provider, and its role will be to organize input data from the API request into various CICS containers, and then pass that to a CICS program over IPIC. So the boundary between ZOS Connect EE and CICS will be an IPIC connection. Then that request goes to CICS, and the implementation of the API is that linkable program. Let's now get a little more specific and say, well, how would HostBridge, our JavaScript engine, fit into that? Well, very well. So everything stays the same. The only difference is that the API implementation becomes HostBridge, becomes our JavaScript engine. And so it then is that agent that allows you to write a bit of automation language using JavaScript in order to invoke maybe terminal-oriented transactions, multiple linkable programs, and perhaps go after data. This design pattern says the API request comes in, transformation occurs if necessary. We go to the channel service provider. All the inputs are organized into containers. Then a link request flows across IPIC. CICS gets that, now passes control to HostBridge. HostBridge does its orchestration activity, and then the response goes back. Now let's look at the REST client service provider. This is another very viable service provider pattern that IBM is actually promoting quite a bit. Whereas when ZCEE first came out, I think we all kind of envisioned, having these very CICS-ish sort of connections between ZCEE and an address space, or they have the IMS service provider or the CICS service provider. What they've been doing is they've built now this REST client service provider, and that is for ZCEE to be a REST client to any other address space, or for that matter, anything. Because when the REST client service provider sends an HTTP request out, it doesn't really know or frankly care where it's going. And the fact that it might be going to a CICS address space 100 microseconds to its left across hypersockets, well, that's fine. But if it happens to be going on an external network to an Oracle server, well, that's fine too. It really doesn't care. But this design pattern still has the same building blocks of API transformation. Something's going to implement the API. The difference is that with the REST client service provider, the input data from the API request is going to be organized as part of the body content or query parameters that are passed to the address space. In this case, it would be CICS. This turns out to be pretty good for us, for HostBridge, if we happen to be the implementer or the API implementation, because our native tongue, so to speak, is HTTP and JSON. This sort of a design pattern and the other kind of play right into our hand and kind of our approach to doing things. But it really doesn't matter because we have a very generic design pattern that IBM has created with ZCEE, this service provider pattern. And whether you choose the client, the CICS client service provider pattern or the REST client pattern, the results are the same. You're going to do API transformation in ZCEE, and you're going to do some sort of API implementation in HB.js. So I'm going to go ahead and begin to wrap up here. As I said, our objective was to give kind of a 30,000-foot overview to how these products work together, and then dip down a little bit in the service provider patterns to see kind of these building blocks. But in the final analysis, what the message we want to get across is that we think ZCEE is great. And HB.js, our integration platform, complements ZCEE really well. We extend its reach into a broader class of use cases, such as terminal-oriented applications, running multiple programs, adjunct to a single API request, and even accessing data directly. And we have people who do this. They want an API that in order to implement the business objective of the API, they need to access some vSAM data, run a couple of programs, do something else at a terminal-oriented transaction. It all happens in a millisecond or two, and boom, it's done. One of the things we like to show, to throw into the conversation is to make sure that people remember that when you're executing CICS terminal-oriented applications using our product, which runs on the mainframe under the covers of CICS, there is absolutely no screen scraping and no application modification whatsoever. We live and operate on an API under the covers of CICS that allows us to interact with terminal-oriented applications before 3270 data streams are ever created or expected as input. So absolutely no screen scraping. There are two design patterns, as we outlined, that currently exist and work for combining ZCEE and HostBridge, and we think that it's just an ideal fit. So we have created some resources for customers or prospective customers or ZCEE users to kind of play around with. First of all, certainly we on our team are available to interact with you about this, but we've also created an e-book on our website, and you see the URL there. I don't know if that URL is active on your screen, but if you just go to the HostBridge website and in the upper right-hand corner in the search box, type in ZCEE, you'll get to it. It's actually very lengthy. It has lots of examples, and we've actually walked you through the various configuration options to configure ZCEE, and we actually provide you with JavaScript code samples and a whole lot of commentary to help you understand how you get both sides working together. If you're interested in following up and playing around with this, please let us know. We offer HB.js under a free pilot program and would be happy to support you in that endeavor. Finally, call us. We love interacting with customers, and we would enjoy making your acquaintance and figuring out if there's a good fit and if we can help you be successful with ZCEE.